Okay, so we'll continue with the lecture on neural networks from the previous lecture. So, in what is fully connected layer? Fully connected layer or dense layer? Dense layer, it is a layer where each neuron is connected to every other neuron in the previous layer. Each neuron is connected to a layer where each neuron is connected to every other neuron in the previous layer. These layers are typically found at the end of CNNs or other architectures. It's fully connected layers. Now the softmax layer, it is a layer often used in the output stage of a classification neural network to convert raw scores into probabilities. Stage of a classification neural network to convert raw scores into probabilities. Now, then comes the autoencoder. The autoencoder it is a type of neural network used to learn efficient representations efficient representations of the data, typically for unsupervised learning, such as dimensionality reduction. Now, the generative adversarial network, it is a class of neural networks used for generative tasks. It consists of two networks, a generator and a discriminator, which compete against each other. Now, what is transfer learning? Transfer learning, it is a technique where a pre-trained model on a large data set is used as a starting point, where a pre-trained model on a large data set is used as a starting point for training on a smaller task specific data set. For training on a smaller task specific data set. Now, what are hyperparameters? Hyperparameters, they are parameters that are not learned by the model. These are not learned by the model, but they are set before training, such as the learning rate, number of layers, batch size, and the number of epochs. Now, what is neural architecture search? It is a technique used to automate the process of finding the best neural network architecture. Automate the process of finding the best neural network architecture. Now comes the attention mechanism, a mechanism that allows the model to focus on different parts of the input, focus on different parts of the input sequence when making predictions. Commonly, this is used in natural language processing. Then comes a transformer. It is a neural network architecture that relies on self-attention mechanisms, and it allows for parallel processing and improved performance in natural language processing tasks. Then comes self-supervised learning. It is a learning paradigm where the model learns to predict part of the data from other parts. So it is predicting a part from other parts. This is useful where labeled data is not there. where the model learns to predict part of the data from other parts. It's useful in settings where the labeled labeled data is scarce. Now, learning rate decay. Learning rate decay, a technique to reduce the learning rate over time during training to help the model converge more smoothly. Then comes momentum. Momentum is a technique used in gradient descent to accelerate convergence by considering the past gradients when updating weights. So it is about accelerating convergence when past gradients are considered when updating weights. Now, what is weight initialization? Weight initialization, it is the process of setting the initial values of weights before training. The process of setting the initial values of weights before training. Proper initialization can help avoid problems like vanishing or exploding gradients. Then comes cross validation. It is a technique for evaluating model performance. It is a technique for evaluating model performance by splitting the dataset into. So it evaluates model performance by splitting the dataset into multiple subsets and training testing on different combinations of them. This is a very interesting and important thing. Cross validation. So you are splitting the data set. You are basically what you have to do. You want to evaluate the performance of the model. It's by splitting the data set into multiple subsets and training testing on different combinations on them. So that is about all in the second part of this lecture of on the previous on neural networks. Thank you.